Déjà, c'est aujourd'hui.
Okay, in this series of videos, we're going to take a look at valuation. In particular, we will look at stock valuation, or coming up with an estimate of the value of a share of company stock. And then we'll also look at valuing businesses as a whole. So as we look at valuation, we're going to consider a variety of different models and methodologies. The first kind of category of these is going to be cash flow models, or valuation based on cash flows for a firm. We're going to look at dividend discount models and a free cash flow valuation model. And then the second large category of valuation is based on relative valuation. And that's where we look at the multiples of earnings or multiples of book values. In particular, we look at the transactions involving other firms, and we compare ourselves to those firms to come up with an estimate of value. So why don't we get started with looking at cash flow models, and in particular a very simple model, the dividend discount model, to come up with some idea of stock valuation. So with all assets, what matters in valuation is the size of the cash flows that an investor will receive, the timing of the cash flows that an investor will receive, and then the risk of the cash flows that the investor will receive. So let's just look at each of these in turn. The size of cash flows, as the size of the cash flows that an investor receives get bigger, that's worth more to the investor, and so they're going to be willing to pay more. That's another way of saying that the share price will be higher if the size of the cash flows to be received by a stockholder are higher. The timing of the cash flows also matters. The sooner we receive cash flows, the more valuable they are to us because of the time value of money. So if large cash flows are coming sooner to us, that's good. If large cash flows are coming a long time in the future, that's going to diminish the value, everything else being equal. So we want to get cash flows as soon as we can. And then finally, the risk of the cash flows matter. If the risk associated with the cash flows is higher, the investor is going to put a lower value on those because of the uncertainty associated with receiving the cash flows. So we got these three factors that we want to keep in mind as we talk about valuation. Now with stock valuation, the cash flows we're considering are the initial investment, the dividends that we receive, and then any proceeds that we receive from the sale of the stock. So those are our cash flows as a stockholder. And let's develop more of this dividend discount model. So with this basic stock valuation model, the price today, and that's denoted with P sub 0 here, is going to be equal to the present value of all the future expected cash flows. So all the dividends that we receive in the future. If we assume for a minute that we're going to hold this indefinitely, we're never going to sell it, we would get an endless stream of dividend payments. And those are denoted by D1, D2, D3, all the way up to DN. Again, where the N is a subscript indicating time, and that's going to be some arbitrarily long point in the future. A little bit more on the notation here. We've already talked about the P sub 0, that's the price today, or the value today. P sub T will simply be the price or the value at any time period T. And T is a variable it could take on any value. D1 is the dividend next year. That's time period 1. D sub T is going to be the dividend at any time period T. And then finally, R sub S is going to be our required rate of return for the stock. That's also going to be called the discount rate for our valuation. So let's assume kind of the simplest case to begin with, and we'll assume that the dividends are going to remain constant forever. So if the dividends are the same, what we're left with is a perpetuity where the cash flows are D, and the discount rate is that rate we just talked about a minute ago, the R sub S. So the value of a perpetuity is a very simple formula, and it's going to be equal to the cash flow divided by the discount rate. So in this case, it's D divided by R sub S. So for a firm with a constant dividend payment that goes on forever, our value would be P sub 0 is equal to D over R sub S. So as a quick example, let's just look at a firm and assume that they will pay $2 per year in dividends. That's going to remain constant forever. And that the discount rate is 10%. So the value of the stock would be the dividend divided by the discount rate. So $2 divided by 10% or 0.1, and that's going to give us a value of $20. Now I just want to real quickly take a side trip to Excel here and look at this case we're just talking about. If we have dividends that last forever at $2 and our discount rate is 10%, I've gone ahead and put the key information up here. We've got the discount rate, the growth rate. So the growth rate is 0. We've got constant dividends. And I've gone ahead and put those in, and you can see I've got years 1 through 19 showing, and all of those dividends are $2. I actually went down all the way to 499 years, so an arbitrarily long period of time, and you can see the dividends are $2 for the full period of time. So this third column I've added is the present value of each individual cash flow. So if you look at this number here, $1.82, that's the present value of $2 received 1 year from today, discounted back at the discount rate of 10%. So that first payment of $2 received a year from now is worth in today's dollars $1.82. Likewise, the second dividend payment of $2, if I discount that back 2 years at 10%, that's worth to me $1.65. So the definition I talked about a minute ago, that the value of any asset is the present value of all the future cash flows that you receive. In this little example here, we're receiving 499 payments of $2 that happen every year, and those are getting discounted at a rate of 10%. So I'm going to add up all of these numbers, all of this row here, all of this column that shows the present value, and that's actually in this cell right here. So I've added up 499 payments, the present value of 499 payments, and you can see that that does indeed equal $20. So that's the value of the perpetuity. In this case, 499 years approximates forever. But I want to look at a couple other things real quick. We've got here the present value of all the cash flows received in the first 20 years. And you can see that that's 85% of the total value. So years 21 through 499 are only 15% of the value of those cash flows. And the present value of the cash flows received in the first 40 years is about 98%. So again, the vast majority of our value comes relatively soon. So we don't have to worry too much about this forever idea. We don't have to get too wrapped around the axle and thinking about, well, gosh, what if this company doesn't last forever? Really, what we're talking about, if our horizon is for the next 40 years, that's close enough to forever for us. So let's go back to the slideshow here and extend the model a little bit, add a little bit of complicating factors. So now we're going to relax the assumption that the dividends have to remain constant, and we're going to allow them to grow by a constant amount each year. And I should say grow by a constant percentage. So we've got this new formula. P sub 0 is equal to D1 divided by 1 plus the discount rate raised to the first power. And then you can see each of these subsequent terms, I'm growing the size of the dividend. So in this piece here, D1, I'm growing it by 1 plus the growth rate. So it's going to be bigger than D1, and it's going to be bigger by G%. And I'm going to discount that 2 periods. And you can see each period the dividend is growing by this growth rate G. So if I add up this infinite sum, what I'm left with is this formula down here below, where the price today, P sub 0, is equal to D1, so that's the next year's dividend payment, all divided by RS minus G, so the discount rate minus the growth rate. Now, I have a separate video that goes through the derivation of this formula. Here I'm just going to skip over the derivation to keep moving, but if you're interested in how that infinite sum simplifies to this very nice little formula here, this constant growth formula, then you can take a look at that optional video. So with this constant growth model, we have this, again, this very simple formula. The price today is equal to the next period's dividend divided by the discount rate minus the growth rate. So let's look at a quick example here, and we're going to assume that a company just paid a dividend of $1 a share. What is the price of the company stock if the dividend is expected to grow by 5% per year and the discount rate is 12%? Now, the first thing we need to do, there's a little bit of a code in this example, and that is this wording where it says the dividend just paid. So that is not D1, that is actually D0. D0 is the shorthand for the dividend that was just paid. It's been paid in the past. D1 is going to be the dividend received a year from now. So we can use this formula, D1 is equal to D0 times 1 plus the growth rate. And that way we can come up with what the next dividend is going to be, what D1 will be. So again, the dividend just paid is not the next year's dividend. Next year's dividend is going to be 5% bigger. So let's look at the solution here. Price today is equal to $1, growing by 5%. So we're going to multiply it times 1.05. And then we're going to divide that all by the difference between the discount rate and the growth rate. So we're going to divide that by 0.12 minus 0.05. If we put that all in, we get a value of $15. And let's just go back to Excel and put that stuff in. I'm going to put the discount rate of 12%, a growth rate of 5, and the dividend of 1. And I want you to notice real quick that we solved for it a minute ago when we got $15. Now if I add up all of those present values, it's showing us $14.29. But it's because I put in the wrong number here for my first dividend. My first dividend to be received at time period 1 is not $1. $1 was the dividend that was just paid. My very first dividend to be received in the future is $1.05. So if I change that input and let everything grow by 5% from then on, I do indeed get the present value of $15. So it's important to keep in mind what dividend you're talking about. Again, the code dividend just paid is equal to D0, and we need D1 for our valuation model. Now, I do want to point you to this more generalized model as we finish this video, and that is the price at any time period t is going to be equal to the next period's dividend. So the dividend at time t plus 1, all divided by RS minus G. So we can generalize that to find the price of a stock at time period 10, the price of a stock at time period 20, etc. We're just going to be looking always at the next dividend payment, the subsequent dividend payment. So we're going to stop here and we'll pick up with non-constant growth in the next video.
C'est passé dans ma vie. Et si je t'attends ce soir tout seul ici, c'est que tu as oublié ce qu'on avait dit. Des fois, l'amour s'enfuit sans se souvenir de l'espoir mis en lui. Mais ce n'est jamais si noir, juste un peu gris. Et si je suis seul ce soir,